Find the equation of a tangent line to the graph of the function when x equals pi thirds. And we have f of x equals 3x times cosine x. Just a product rule. All right, so remember the derivative of a product, right? It's going to be the first times the derivative of the second plus the second times the derivative of the first. All right, so u here is 3x, derivative is 3, and then v is cosine x, derivative of that is negative sine x. All right, so we have the first, so we have f prime of x. F prime of x is 3x times the derivative of the second, so negative sine x, plus the second times the derivative of the first. So it would be 3 cosine x. All right, and let's just do one last thing. Negative, move from the negative with the 3. Negative 3x, negative, drop the parentheses, sine x plus 3. All right, so find the equation of a tangent line. We're just going to plug in pi thirds. All right, so this was this part here was number 1. That's our derivative. Number 2, we got to evaluate our derivative. So we have f prime of pi thirds equals negative 3 times pi thirds sine pi thirds plus cosine pi thirds. All right, so pi thirds in the first quadrant, because that's less than a half. All right, opposite pi thirds, that's like 60, that is, not like, it is 60 degrees, same as 60 degrees. So this is the square root of 3, this is 1, this is 2. All right, so sine, let me just finish writing this. All right, here I can cancel out the 3, so this is negative pi. And then sine pi thirds is going to be the square root of 3 over 2. And then plus cosine pi thirds is 1/2. Right? Oops, lost a parentheses. So not a very pretty number, right? But that is our slope there. We could make that one fraction though. So we could, they both have a denominator of 2. We could say negative pi square roots of 3 plus 1. Or you can put the 1 first if you don't want the negative, all divided by 2. All right, so now all we need is the y value. And then we can write the equation of our tangent line, even though that's not a very pretty looking slope. All right, so f of, so this is part 3 here. F of pi thirds is 3 pi thirds cosine pi thirds, right? And so that's going to cancel. That's just going to be pi and then times 1/2. So pi divided by 2. All right, and then so finally, part 4, we write the equation. All right, so we derivative, evaluated to find the slope. All right, this is the y value. All right, so this part here was the derivative. And then the slope. And then the y value. And now we can write the equation. All right, so our last step is equation. So we have y minus pi halves equals that negative pi square root of 3 plus 1 divided by 2 times x minus pi thirds. And no part of me wants to distribute that. And so we'll just isolate y. Y equals negative pi square root of 3 plus Oh, and it's the whole thing. Whole thing times plus 1 divided by 2, all multiplied by x minus pi thirds plus pi halves. That has got to be one of the ugliest looking equations I've ever seen. But technically it is a function, it's a linear equation. If we simplify that all out, it's just really, really irrational. So we're just going to leave it like that. All right, 2 done. I like problem 2 better than problem 1. How about problem 3? Find the equation of the normal line to the graph of the function below when x equals -2. All right, first thing we got to do is find the derivative. This one is a chain rule. All right, and so we have the outside, so it's going to be the derivative of the outside times the derivative of the inside. All right, so we have f prime of x equals, oh, let's rewrite that. All right, so f of x equals 3x minus 2 to the 1/3 power, right? And so don't get yourselves confused, it's just blop, right? So f prime of x is going to be, actually let's do each part. So if let's make the u the outside, right? So u is just blop to the 1/3. du is going to be 1/3 blop to the -2/3, and we know we've got to replace the blop, right? And that's just 3x minus 2. Right, so our blop is just 3x minus 2. Right, and then we need the derivative of the inside. Right, so the inside part is the 3x minus 2, and that derivative, boy, my u and my v don't look too different, is just 3. All right, so our derivative, f prime of x, is going to be the derivative of the outside, so 1/3 times 3x minus 2 to the -2/3, all times 3. Well, the 3 and the 1/3 will cancel, and so f prime of x equals 1 over 3x minus 2 to the 2/3 power. All right, so there's our derivative. All right, step 2. We need to evaluate when x is -2. All right, so we have f prime of -2 is going to be 1 divided by the square root of 3 times -2 minus 2, and that's raised to the 2/3 power. Right, and that's the same as, I'm going to rewrite that. I find it easier if I'm evaluating to make that the cube root, and that whole thing is squared. So we have f prime of -2 equals 1 divided by, all right, so that's going to be -6 minus 2, that's -8. That's nice. We got a perfect cube. So the cube root of -8, and that whole thing is squared. So f prime of -2 equals 1 divided by, so that's going to be -2 squared, and so that's going to be 1/4. All right, so this is the slope of the tangent line. All right, slope of the normal line, you flip it, change the sign, right? Because these are perpendicular lines, right? Tangent line is perpendicular to the normal line. All right, so our normal line, the slope is going to be just -4. All right, so now we need to write the equation. So we need to figure, it's going to go through the exact same point. So we do need to know f of -2. All right, so that's going to be the cube root of 3 times -2 minus 2. So that is just the cube root of -8, which is -2. All right, so we have y plus 2 equals negative 4x plus 2. So here our point was negative 2, negative 2. Right? Our slope is negative 4. The point is negative 2, negative 2. We plugged in negative 2. We got negative 2 out. Right? And so y equals negative 4 times x plus 2 minus 2. And that has to be one of our prettier equations. And you can make it that, or you can make it, that'd be negative 8. That'd be, if you want to make it y equals negative 4x minus 10, right? That would be the exact same thing. All right. 3 down, only 1 to go. They're getting better each time. At what point on the graph of the function f of x equals the square root of 3x minus 2 is the normal line perpendicular to the line defined by the equation y equals 1/4 x minus 3. Phew. All right. Well, we already know the derivatives. Cube root 3x minus 2. Oh no, it's the square root of 3x minus 2. So close. So close. Got to find the derivative. All right, so that's because that's the only way we're going to know what the normal line is. So first part, let's find the derivative. F prime of, so we're going to have the outside and the inside, right? So the outside is going to be u, right? So u equals blop to the 1/2 power, right? Because this is a chain rule again. And so the derivative is going to be 1/2 blop to the negative 1/2. Right? So this is the outside. The inside is the derivative of 3x minus 2. So v here is 3x minus 2. That derivative is 3. Right? So f prime of x is going to be 1/2 blop to the negative 1/2, or 1/2 3x minus 2 to the negative 1/2, all times 3. Let's simplify that. F prime of x equals, so we're going to, only the 3 is going to be in the numerator. 3 divided by 2 square roots of 3x minus 2. That's our derivative. Yay! That's part 1. All right, part 2, we want to find out what point on a graph of the function is the normal line perpendicular. All right? So, normal line, if that's our slope, right? Well, let's work our way backwards. So, if the normal line is perpendicular to y equals 1/4 x minus 3, right? So the slope here is 1/4. The normal line, the slope is going to be negative 4. It's kind of like that last problem. Right? So too bad it wasn't the exact same problem. We know exactly where it was. All right, so the slope here that we're looking for is negative 4. We want the normal line to have a slope of negative 4. All right, so the slope is going to be negative 4 in the same place, because we don't have anything to work with the normal line. So where this one is negative 4, it's going to be in the same place where the tangent line is 1/4. So now let's set our derivative, 3 times 2 square roots of 3x minus 2. So this is the next part. Let's set that equal to 1/4, right? Because where the tangent line has a slope of 1/4, the normal line will have a slope of -4. Make that a little bit neater. Of -4. All right, so you have a proportion here. Let's cross multiply. All right. By the way, you can reduce proportions within a fraction along the numerator or along the denominator. So let's reduce that. All right. So that's going to be a 2. All right. So now we have 3 and square root of 3x minus 2 equals 1/2. Just cross multiply here. So 3 times 2 equals the square root of 3x minus 2. All right, and now 6 equals the square root of 3x minus 2. We have to get rid of that square root, so we're going to square both sides. So 36 equals 3x minus 2. Add 2 to both sides. 38 equals 3x, and then divide by 3. Just leave it like that. X equals 38/3. That's where. All right, and only so what point? We're not quite done. Not quite done. That's the x. It's at what point? All right, what point? We need x and y. So we have x. Let's find y. How do we find y? Plug it back into the original function. All right, so here's how we find y. Right, we take f of 38/3, which actually is going to work out okay. Square root of 3. We're actually going to get a decent number. Go over a little bit. 3 times 38/3 minus 2. Right, and that's going to be, that'll cancel. The whole thing's under the radical there. This will be the square root of 38 minus 2. And that's just the square root of 36, which is 6. All right, so hopefully you could follow all of this. We found so step number 1, we found the derivative, because we can find the derivative. All right, that's the one thing we can find. Step number 2, normal line had to be, if the normal line is going to be -4, the tangent line's got to have a slope of 1/4. We set our derivative equal to the slope, because we're solving for when that slope is 1/4. Anytime you want to know where the derivative is equal to any slope, you just set this derivative equal to the slope. And then this is the x. If we substitute back into the original function, so we substituted to find y, and now we have the point, and our point is dun, 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 and we're going to be done. Our point is 38/3 6. That's where. All right, so the answer to the question, the graph, the normal line. So it says at what point? So the normal line is perpendicular to y equals 1/4 x minus 3 at the point, and I should put the normal line of f of x. Boy, the writing up there is not good. normal line of f of x is perpendicular to y equals 1/4 x minus 3 at the point 38/3 6. It's a good thing it's written below because it's pretty wonky up there. And that's it. All right. In the next lessons, we're going to actually go back and look at some more advanced trig functions before we move on and do anything else. All right. Bye for now.